Building Information Modeling, or BIM, is becoming a better-known established collaboration process in the design and construction management. Owners are increasingly requiring BIM services from the architects, engineering firms, and construction managers. Many construction firms are now investing in BIM technologies during bidding, pre-construction, construction, and post-construction. The approach to implementation of BIM is varied with different softwares applications like Revit Architectures, Revit Structures, Revit MEP, Autodesk Inventor, CATIA, Rhino, SolidWorks, and among the others. The objective of this presentation is to explain the significance of BIM principles and application of it in design, engineering, and construction industry. So what is BIM? According to the Autodesk company, it defines the building information modeling as a process that begins with the creation of an intelligent 3D model that enables document management, coordination, and simulation during the entire life cycle of the project. BIM represents the process of developments and the use of computer-generated model to simulate the planning, design, construction, and operation of the project. It carries all the information needed for the building, including the physical, functional, character, and project life cycle information. It characterizes the geometry, spatial relationships, geographic information, quantities and properties of building elements, cost estimates, material inventories, and project schedules. It documents the work in drawings, procurement details, track the submitter process, and building specifications. BIM is used for design analysis and creating design options for stakeholders to easily visualize the building before it is built and to coordinate vital information for all disciplines. The Autodesk summarizes the benefits of BIM and how significant it is in architecture, civil engineers, MEP, engineers, constructions, factories, plants, and structural engineers. Architectures. According to Autodesk, it makes better design decisions, improving building performance, and collaborate more effectively throughout the project life cycles. In civil engineers, it can be used as an intelligent, connected workflow to help improve predictability, productivity, and profitability. In construction, it digitizes your construction site and connect project information from design through construction and handover. In factory and plant, you can manage the design and construction of intelligent piping structures and processes more efficiently and collaboratively throughout project life cycle and at hands-off. In MEP, you can improve the mechanical, electrical, and plumbing design quality and collaborate in real time to support the product delivery process. In structural engineer, according to Autodesk, it explores how structural design and detailing softwares help to win new business and support project delivery. What are the significance of BIM? According to United Nations, by 2050, the world's population will be approximately 9.8 billion in 2050 and 11.2 billion in 2100. Thus, to maintain a more sustainable social and economic space for human inhabitants, the architects and engineers must deliver infrastructures and buildings that suits on factors that affect on human lives. As a response, the architects, engineering, and construction industry must design a more efficient, resilient, effective, and smarter approach in building designs and constructions. In BIM, collaborators in design and construction teams can work faster and efficiently in precise manner that captures information data and reports for the project. The following would be the benefit of BIM: coordinations and collaborations, conflict detections and risk mitigations, high level of customizations and flexibility, optimizations of schedules and cost, easy maintenance of building life cycles, and faster drafting without loss of cost and quality. Furthermore, the applications of BIM solutions to project might result in higher quality works, greater speed and productivity, and lower costs for building industry professionals in the design, constructions, and building operations. What are the risks of BIM? Though BIM can create profitability in the project, still it has known and unknown risk that matters and must consider in project life cycle. Here are possible issues and risks that need to think throughout the design and project management with BIM. Ownership. Who will own the model? How is the cost of the model being spread, shared, or allocated to other disciplines? Who has the right to use the model? Who owns the copyright to each part of the design in the database? Who controls the process of creating and updating the model? Next risk is the reliance. Who is responsible for BIM errors? Is there any limitation of liabilities in the contract? Who would be the parties involved or deal with evolving technologies or large changes in the softwares or capabilities affecting the model? Does the contract contain a waiver of conceptual damages arising from use of the BIM process? Who is responsible of liable for translations error between differing BIM platforms? Are non-BIM contractors or suppliers third-party beneficiaries of the BIM suppliers or its outputs? If so, to what extent? So therefore, incorporating the relevant items below in the contract documents or other relevant enforceable provisions of the project would help in clarifying the above issues, the ownership and the reliance. Wherever possible, the terms and conditions incorporating these issues should be fairly and openly negotiated among the stakeholders. What are the mandates of BIM globally? In 2017, the BIM Innovation Capability Program, or BICP, produced a report globally, and here's the report. According to Global BIM Regulation Evolutions, we only have these countries that already mandated the use of BIM in construction, design, and engineering processes. The Dubai already mandated since 2013, the Hong Kong already mandated in place since 2014, the Norway, the Singapore, and the United Kingdom. So based on the information reproduced by Stroma certification site, countries like Dubai, Hong Kong, Norway, Singapore, and United Kingdom are those who already experienced the full implementations of BIM in design and construction management. The rest are still planning, already planned, and ready for implementation for the coming years. What are the processes of BIM? The process of BIM supports the creations of an intelligent building model throughout the project lifecycle. The first process is the planning process. It informs project planning by combining reality captures and real-world data to generate context models of the existing built and natural environment. The next process is the design process. The design process, during this phase, conceptual designs, analysis, detailing, and documentations are performed. The pre-construction process begins using BIM data to inform scheduling and logistics. The third process is the building process. During this phase, fabrication begins using BIM specifications. Project construction logistics are shared with trades and other contractors to ensure optimum timing and efficiency. And the last process is the operation process. BIM data carries over to operations and maintain of finished assets. BIM data can be used down the roads for cost-effective renovations or efficient deconstructions to the building. What are the differences between CAD and BIM? BIM softwares are similar with CAD. That technically BIM softwares are under the CAD umbrella, but however, BIM and CAD represents different approaches with regards in building design, engineering, constructions, and documentation. The CAD, or computer-aided design application, imitates the traditional paper and pencil processes insofar as two-dimensional electronic drawings are created from 2D graphics elements such as lines, hatches, text, etc. CAD drawings similar with traditional paper drawings are created independently from each other. Thus, design changes or revisions need to be followed up and implemented manually on each CAD drawings. On the other hand, BIM or Building Information Modeling application imitates the real building process. Instead of creating drawings from 2D line works, buildings are virtually modeled from real construction elements such as walls, windows, slabs, and roof, etc. This allows architects to design buildings in a similar way as they are built. Since all data is stored in the central virtual building model, design changes are automatically followed up on individual drawings generated from the model. With this integrated model approach, BIM not only offers significant productivity increase, but also serve as the basis of better coordinated designs and a computer model-based building. In BIM, the building information is stored in a database instead of in a format drawing predicted on the presentation format. It is a modeling solution that creates and operates on a digital database for collaborations and change management. This information is preserved to use and reuse in any project phases. So what are the dimensions of BIM? The building information model can be used for visualizations, fabrications, and shop drawings, code reviews, forensic analysis, facility management, cost estimating, construction planning, and project management, and conflict interference and collision detections. So, the following are the inclusions on various dimensions of BIM. Here is the 3D dimensions. Existing condition model, laser scanning, ground penetrations, radar, GPR conversions, safety logistics, models, animations, rendering, walkthrough, beam-driven prefabrications, laser accurate beam-driven field layout are under 3D dimensions. So you have X, Y, and Z. Okay. In 4D dimensions, another dimension is added. This is the scheduling, project planning simulations, lean scheduling. So this the fourth dimension is the time, right? So it includes the schedules, there's a time, equipment deliveries, detailed simulation installations, visual validations, or payment approval. In 5D, we are including the fifth dimension is the cost or the quantity, the material takeoff, the estimating, real-time conception modeling and cost planning, quantity extraction to support detailed cost estimates, trade verification from fabrication models like steels, rebars, plumbing, electrical. We are doing also the value engineering and prefabrication solutions in 5D. The next is the 6D. 6D is the sustainability. We are talking about the sixth dimension is the structural analysis, the conceptual energy analysis. So we are doing analysis in 6D. The detailed energy analysis, sustainable element tracking, LEED tracking, and structural analysis. Everything about analysis in the sixth dimensionals of the building. The last is the 7D. 7D is the facility management applications. Lifecycle BIM strategies. BIM as built, BIM embedded, operations and manuals, COVID data population and extractions, BIM maintenance plans and technical supports, BIM file hosting on land lease digital exchange system. So how is the documentation process in BIM? An immediate challenge on building information modeling is managing files. We have a large tons of files in our offices. So distribution of it and communication of every discipline is very hard to each one of us to get information, to send the information for input and output, etc. So the question of how to store and distribute large files and manage the review and approval across different parties. Due to this demand, electronic document control is necessary, like the Aconex. On this type of controlling project documents, all documents will be delivered online. With an online account, the project stakeholder has the right to view the streams event without downloading the full model of the project files. so he can access it online. Through this system, the company using BIM can save tons of papers, it's environment friendly, and printer ink for the entire project life cycles. So what is the future of BIM? Building Information Modeling, or BIM, is emerging as an innovative way to manage project. Building performance and predictability of outcomes are greatly improved by adopting BIM. As the use of BIM accelerates, collaboration within project teams should increase, which will lead to improved profitability, reduced cost, better time management, and improved customer-client relationships. Building Information Modeling solution creates and operates on digital databases for collaboration, manage change throughout those databases so that a change to any part of the database is coordinated in all other parts, and captures and preserve information for reuse by additional industry-specific applications. Through the application of information technology to the problem of describing a building in softwares, they enable higher quality work, greater speed, and improve cost effectiveness for the design, construction, and operations of the building. Building Information Modeling offers the capability to develop project cost information with more accuracy throughout the entire building life cycle. The key to successful use of BIM-based project would be the development of processes and methods within the organization. Thank you for listening and watching these videos. I hope you learned something about the significance of BIM, and please remember that adapting to the advantages of BIM requires investment in staff, processes, and technologies. Approaching these changes with a positive attitude will speed the transitions and allow firms to quickly realize the productivity and quality gains possible with BIM. Thank you very much, and bye-bye.